back in the garage, ready to get going on this PTV build again. In the last video, we finished fabrication on the tracks, so those are ready to go. Nothing else needs to be done with them. They turned out great. I'm really happy about that. So in this video, we are going to move forward and get some work done on our engine, the drive pumps, and hopefully get that whole component wrapped up just like we did with the tracks. I'd like to get that whole stage of the build done so that when we get to actually putting the chassis together, we can just focus on what we're doing and start putting the larger pieces together to make that whole machine work and yeah, get that going. Like I said in our kickoff video, this is the engine that we are hopefully going to be using for this PTV build. It's a 13 horsepower single cylinder Honda clone. It's a little tired. It's been sitting outside for a couple years. It hasn't been run. The fuel in it is more than likely no good anymore, and so we need to get rid of that. We need to go through the carburetor, make sure that it's not all gummed up, and basically make sure that the engine's going to be functional before we put too much time into getting it ready for this part of the build. So once we get the engine running and we have a little bit of confidence in it, we'll move on to our pump mount bracket. So I had these parts laser cut. We will begin to do the fabrication for these. There's this plate here that goes onto the engine. There's another plate here that's going to actually sit out a little bit. In between them is where we're going to run the pulleys for the pumps and the power transmission, so we'll get that all set up. A lot of little pieces that need to come together to make this actually work quite nicely. It's going to take a little time to make everything look really good. Something else we're going to have to do is we're going to have to do a little bit of modification on these pumps. So this top section here that you see is actually an auxiliary pump. The main part of this pump is really only good for driving a track or a tire. You can't really operate any other kind of implement from it. So if you had these on a zero-turn mower, for example, the main pump would be solely used for driving the wheels. If you needed a deck lift or some other kind of implement, you need to lift it up or move it around, it's this auxiliary pump that would be used for that function. And we really don't need that on the PTV. We're going to take these auxiliary pumps off and swap them onto the mini Snowcat because it has the normal charge pump cap, and that's what we want on the PTV. So a little bit of swapperoo between this and the mini Snowcat. Taking a look inside of the tank there, and it's not too bad, but it's also not too good. It's going to need a good clean out. There's some rust sediment in there, and it doesn't look too bad. It doesn't look overly rusted. Some of that coating on the inside is still in good shape, so that's a good sign. So what we'll do is we're going to take the tank off, empty out whatever remaining fuel is in there. Once we get that cleaned out, put some fresh fuel in there, of course. Also going to take this carb off and we'll get it on the bench and make sure that everything is functional in it. I'm sure some of those passages, the little seats and everything, are all gummed up, so we'll make sure that that's all working, and then we're going to go ahead and get this engine started up. Got the float bowl off. Here's the verdict. It's pretty grimy in there, so that is gonna definitely need a little bit of TLC. I'm hoping that the rest of the carb isn't that bad. Most of this is just rust actually, so hopefully we can get that cleaned up and don't have to worry about this anymore. Well, after about 3 minutes of working on this, I've decided that it is not in my best interest to put any more time into this because it is just too far gone and it really will just be a waste of time. So I'm going to go ahead and just order a new one on Amazon. It'll be here in a couple days, and then we won't have to worry about this. It'll just be much better than trying to make this thing work to any decent capacity. I'm not worried about the engine overall. I mean, I'd say if anything is going to cause issue, this would be it right here. So once we get a new carburetor on there, we really shouldn't have any other issues. So I'm going to leave that for now. We will address the tank and a couple other things on this, and then we're just going to move on to the fabrication for that pump mount. Right. Things are evolving rapidly around here. I remembered that I had another one of these 13-horse engines that I ended up scrapping. Went out to my shed as a classic Ukrainian, never get rid of anything, and I have this carb off of that engine that I had salvaged before I tossed the block. And look at that. It is in absolutely perfect condition. So we don't need another carb. This one is a little dirty on the outside, but on the inside, it is absolutely perfect. So we're going to go ahead, just tidy this up, make sure everything's okay with it. And this should be exactly what we need to get our engine running tonight. Okay, well, we got this replacement carb cleaned up. It just took a little bit of parts cleaner and it's looking almost as good as new. It really didn't have a lot of time on it. That engine failed because I guess one of the rings had let go and it just had no more compression. So it was actually it would have been the equivalent of a GX 420, which I believe is the 15 horsepower. So putting this onto the 13 horse shouldn't have any problems. We might need to just dial the fuel mixture back a little bit, but overall it should be a direct bolt-on, and that means that we can get this engine up and running a lot sooner. Turned out pretty good. I managed to get almost all of the grunge out of the tank. It was just sediment, like rust or anything, so that turned out really good. All I did is I put some parts cleaner in there, just used a paintbrush. I didn't want to scratch it up, so I just used the paintbrush because it was soft, and just kind of gently washed around in there, emptied it out, rinsed it out. It's all good to go now. So fuel tank's done. Carburetor should be in good condition. We'll check the oil here, make sure that we have something in there. Yep, that's good. It's spilling out everywhere. Actually, that looks pretty clean. So yeah, I think we're at the point now where I might just throw a couple clamps on it to hold it in place. We'll add some fresh fuel into it and see if we can get this thing started. I think we've got our engine here. That started up absolutely beautifully. I didn't put any fuel into the carb. That was all just filling it up, giving it a couple pulls. So that's really positive sign to see that this starts up so beautifully. At first I thought this way was choke. No, that was wrong. As soon as I moved it over to the choke and gave it a pull, that was all it took. So that's a great sign. That means that we can continue getting this engine set up with the pumps and getting everything put together now. Well, I'm really excited that that engine is running. That is a big deal, because having to spend money on a new one, not gonna happen. That would have been the end of this whole build series. So like I said, I'm really pleased that it's working. Now we can move on to the pump mounts and the rest of that engine. So The plan, at least in my mind for now, is to have the engine mounted with the PTO actually pointing backwards in the track vehicle, so that the pumps and everything are at the back part of the machine overall. So imagine that, yeah, it's pointing forward, we have some type of mounting plate on the machine, and then after that point we really don't need anything out from that point. Playing with a couple different pump configurations, and I'll be completely honest, when I originally planned these plates here, I had not fully considered that the PTO, the actual like mounting surface of the engine, wasn't completely, I guess, what would you say, even all the way along. So you can see pretty much everything is in line with that, except for the exhaust, and that's where things were getting in the way. And you would have seen where I had this whole system flipped downward. I really didn't like that. So what I came up with is just using a piece of spacer tube in here. It's just a piece of 1/8 inch walled tube. I'm gonna say it's 4x4 a square. Just use that as a spacer to give us a little bit of room to get the mounting plates away from the exhaust. We still have enough purchase for the drive pulley to get connected to the PTO of the engine, and everything's going to work out okay. I just like this arrangement a lot better. It keeps everything in line. The other thing it does is you got to keep in mind that when the drive belt is running around the pulleys, it's getting pulled basically along like this direction. This, I guess you'd call it span or section of the belt here. This one is under tension. This top one is under tension because it's coming back along here. And so the slack part where you want to have your belt tensioner needs to be somewhere along this section here. And again, that's kind of how I had envisioned this whole setup to kind of be put together, is to have it running so that it's going around like that, and then the tensioner would be somewhere in this area here. Using this piece of square tube in there, we're going to be able to still achieve that. And overall, it just keeps everything nicely aligned, and it also gives us space in this area here to mount our reservoir. Keeps everything out of the way, keeps the oil filter that spins on at the bottom, it keeps that kind of up above the bottom of the machine. So yeah, overall, we're going to go with this because this is my original plan and I still like it a lot. Now, the one flaw in that, I'll admit another flaw that I had, or mistake I had made, is when I drew up this part in CAD, somehow, for some reason, on this engine side plate, I deleted the holes that are supposed to be here and here. They're just supposed to be a regular 3/4 inch hole, and yeah, they disappeared somehow. I wasn't paying attention. What we'll have to do is sandwich these plates together with some bolts into these holes here, drill them out on the mill drill. No big deal. We can overcome that little bit of an issue there. Yeah, we're going to continue to get the setup going with this type of setup, and I think it's going to work out pretty good. Well, I took a little break. I wanted to make sure I had the right parts to be able to get this belt set up. And fortunately, in my box of belts, I had ordered 3 of these cogged BX42 belt. And I had actually ordered these for the Mini Snowcat. They were too small, but luckily they actually are going to work on this setup here. What I ended up doing is getting a couple different sized pulleys. What I'm going to end up with on this is having a 5-inch on each of the pumps, and we're going to have a 6-inch on the drive shaft of the engine. That's going to basically do an overdrive scenario of 20%. So we'll be a little over 4,300 RPM, I think, at that point. when the engine's running full out. 4,300 on the pump side. The engine will just be set for 3,600 as usual. That'll up our flow ability a little bit. We might need to revise that later on and bring that down slightly. So I do have a 5.5 inch. I also have a 5-inch pulley, but if we go down to the 5-inch, we're going to have to find a BX41, a 1-inch shorter belt, just because there's going to be too much slop in there. So I'd like to try and use these belts first. They are not cheap. I think they're around 35, 40 bucks a piece. I have 3 of them. That would last quite a long time. And considering I have the parts to make them work, why not just go with that as it is already? So we're going to begin to get the fabrication for the motor mount, or the pump mounts underway. So the first thing there is going to be, like I said, taking these all apart, sandwiching them together, drilling those holes that I'd somehow missed on there. After that, what we're going to do is come up with a little bit better of this spacer here. So I just wedged in this piece of square tubing temporarily. I didn't have long enough bolts, so these are kind of just kludged together. So what we'll do is actually get a plate that will mount against the PTO side of the engine. I'm going to cut another one of these pieces of tube so it'll be basically minus that thread or the plate thickness. And then we're going to get everything set up, and we'll actually end up welding that tubing here to the motor mount plate and to the actual PTO side. So it's basically all one. It'll hold everything in place, and it'll be able to support the weight of the pumps and the reservoir and everything a lot better. This type of setup here, if you weren't to have this welded together, it would be prone to failure. A lot of stress on these little bolts here. So we're going to get moving on that right away. After we're done with that, we've got the actual motor mount all finished, like so, spaced out and welded in place. We can move on to getting tensioner set up. I've got a plan for that. We've got some parts kicking around. Let's take a look at what I've come up with so far for this mounting bracket. I found it was a 5-bolt wheel hub, and it'll work just fine. So I drilled it out, basically using this as a template. So we drilled out the same bolt pattern, and then I've got that piece of square tubing in there that I cut down. So the combination of the tube and that plate is equal to the length of tube that I'd used temporarily for mocking this up. So basically this has become a bolt-on engine adapter plate, and once I get this off and get this all welded up, it'll be pretty solid. So that turned out really good. I also did get these holes drilled out. That was pretty easy on the mill and drill. So the next step now is to cut some 7/8 pieces of rod and machine the ends down to 3/4. And the goal is to get this plate and the pump mount plate, figure somewhere between 2 3/4 and 3 inches. So I want to go 2 3/4, but something inside me says that I always make things a little too compact, a little too tight, and I should probably aim for that 3-inch gap just to make it a little bit more manageable. So yeah, I'll end up landing on 3 inches. So if we cut those dowels to let's say 3.5 or 3 3/4, and just make sure that we machine down that shoulder in this section here to 3 inches, then the pump plate will be parallel to this plate, and everything should line up really nicely. So we're gonna go cut those dowels, machine them on the lathe, and then come back in here to get this put together. Well, there we go. This is all welded together. It turned out really nicely. As you can see, we got our little dowels there machined. They fit inside nice and snug. And both of these plates now are exactly 3 inches apart on the inside, so that gives us lots of room to work. It also gives you room to get belts in and around, all of that stuff. It's just going to be really nice, really simple to work in there. So I even welded the rest of that adapter plate there into place. So the the engine pump bracket is basically done in its simplest part. There is a couple little things that we will need to add. Obviously, there will be a bracket that will attach the reservoir, and there's also going to be an idler arm that we're going to have to fit in here somewhere, but those will be a little bit more ad hoc as we go through this. So the next step right now is to get the pumps bolted on and get our pulleys kind of in place so that we can actually start to get things put together and make sure that it's going to work right. So the next step here is to machine some of these hubs down. These are X type of hubs. They have the larger diameter for mounting a sprocket to them. I actually need a W series, which is what we have here. And the reason that I have the X is really because there was no stock on the W series with the inside bore that I need. These are going to be used for our pulleys. These will go onto the engine and the 2 pumps. So this is part of the whole driveline setup. So what we need to do is just put these into the lathe, no big deal. Turn them down so that these hubs will fit onto them, and then we can continue getting the rest of the engine and pump mount plates mocked up. Well, things are coming along nicely. So I've got the pumps back in here again. I've got the hubs welded to the pulleys now, so that is all basically ready to go. The next item that we need to tackle here is coming up with a tensioner. We have quite a bit of tension slack that we need to take care of. So what I'm thinking of doing, I'd love to have a spring-loaded tensioner. A fixed tensioner that's just a bolt that you kind of like put in place. It leaves opportunity for slack to accumulate, and then you need to kind of go back and retighten it. So ideally, if it's a spring tension to idler, it'll always maintain the correct tension. The other benefit there is you can release that spring pressure, and that gives you a little bit of an advantage starting this thing when it's cold. So this unit, because it doesn't have electric start, to be able to pull start it in the cold weather, it will be significantly easier if you're not trying to turn the engine and turn these 2 pumps at the same time. So the ability to disengage the drives is going to be significant for getting this unit started. We're getting going on a tensioner, and so this is what I've come up with. I'd like to use just 2 of these roller bearings and stack them up in such a way that they will just kind of ride right on the belt, not up here underneath. I'm just making it, doing this up here so it's a little easier to see. And so to get 2 of those bearings basically side by side, what I've done is I just took a piece of 1-inch round bar, put it in the lathe, and I turned it down so that the end here is now 3/4 inch like the bore of these bearings. So these bearings will fit onto the shaft here like this, and it's just sticks out just a tiny bit proud. And what we'll do is we're going to come up with an arm that's going to pivot kind of inside down below there, and it's going to attach kind of right at the edge there, so that basically we can bolt this whole stack of bearings and this little kind of collet, if you will, onto that arm. And that's what's going to basically be our idler wheel. So it's just going to kind of be in this area here, and it'll just pivot up into place to provide tension on that belt. So the next step, now that I have this little chunk of steel done, is to come up with a little arm that's going to pivot somewhere off of either up front here or maybe in the back. And once we get that arm done, figure out a way to get a spring onto it so that we can have constant tension on that idler, and then I think we'll be in good shape. Okay, let's take a look at what I'm coming up with here for the tensioner. So I've got that little collet inside of these bearings here. I have just a washer between the engine plate and this little arm. And so the way this is going to work is it swivels up into, this is the slack side of the belt here. It's not under load. So we're gonna weld this little piece of, or another little piece onto there to make a little L shape. And to that, we're going to connect a spring, and then that'll actually be what keeps this whole belt tensioned. And then if we need to, we'll set it up so you can disconnect the spring, relieve the tension, and then that way the motor, the engine, can actually freewheel. You could get it started, let it warm up, and then once it's warmed up, you can then engage the drive system for the pumps. All right, I'm going to move on from the tensioner for a minute. I would like to get these auxiliary pumps switched over onto the mini snowcat. I've pulled it into the garage now, so it's ready to work on. And basically all we have to do is remove these two top bolts. This top auxiliary pump comes off. The charge pump is actually this little plate in the middle there that's sandwiched in there. So this all comes off, it bolts onto the top of that one. Or, well, obviously that charge pump comes off before we can bolt this one on. All right, well, that was a complete pain in the ass and a waste of time on top of it. I got the charge pump off of the snowcat, and I was trying to get the charge pump from these pumps onto there, but the problem is that there are some little steel alignment dowels, one there, and it actually fits into a little hole on the cap, the top cap of the pump. And the problem is the pumps on the snowcat do not have that, and I realized that when I actually was trying to align this, and I somehow managed to drop them into the bolt holes, and that was a pain in the ass. So I had to use a little dental pick with some magnets on it. Fortunately, those rare earth magnets were able to pull those little pins out of the holes on the snowcat, and I got that charge pump cap back on there. So unfortunately now we have to basically just deal with these auxiliary pumps as they are. Okay, so for now I am done screwing around with the charge pump stuff. That was a waste of time. Well, not a waste of time. We learned something from that. We learned that these auxiliary pumps will not work on the snowcat pumps, so they basically are destined to stay with this. The other thing I can do is, once I've got those O-ring Boss to flare fittings in there, I can just use some low pressure AN fittings to make my own little loop back. These pumps at most can generate about 500 psi, but when you're looping something back like that, there is absolutely no pressure to be built up there. the pressure is really a response to the load being applied to the pump. So if there's no load, there's no pressure. So the only pressure we could ever see is the tubing if it were to get, let's say, kinked or pinched for some reason. That would be the only reason why you'd ever see pressure in that little loop back there. So that would be a really suitable workaround for this, and it'd be pretty inexpensive as well. So I've got them capped up for now. We will leave them like that. That will get tackled when we move on to the plumbing stage of this project, but that is not now. We need to finish that tensioner and get this wrapped up. Look at what I've come up with for this tensioner and how I hope to be able to release tension on the belt for starting it. So I've got, this is my tensioner arm. I added this little piece here where the spring attaches, and then I just used a piece of scrap. This is just kind of temporarily put together. Once we go to assemble this completely, we will use some nylocks and make sure that everything is well seated. So this is the loose position, and when you go to tension it, so we'll just cut this off a little bit shorter, but basically you can just put a bolt through there and that'll lock the tensioner in place, and that gives us a nice tension on the belt, and the spring can absorb any of the slack, whether the belt is stretching or whatnot. So that gives us some good adjustability there. And yeah, if you need to remove it, you just have to pull this little bolt out here that basically locks this lever into place, and you're good to go. So I think this will probably be the simplest solution, something that is easy to use, and you don't have to worry about it coming out when you're out riding on it. So. All right, the last thing that I would like to do for this part of the build is get this filter reservoir mounted between those two pumps there on that bracket. So the bottom of this reservoir has two holes that are drilled and tapped, and I would like to build a little plate that basically holds that somewhere like that. So we're going to have to cut a little piece of steel, maybe out of some 1/4 inch or 3/16. I'll see what I have available. Basically that will hold those two there and kind of give us enough room, enough clearance around that filter there so it doesn't interfere. And yeah, we'll tackle that, and that'll be it. Alright, we've got our reservoir mounted. It is secure now, so that turned out really nice. It works out nice having it right in the middle there. It's going to make plumbing from the inlets and outlets from the pumps really easy. We can just use some transmission cooler lines. It's just low pressure, so we don't really need to get hydraulic lines made up for that. That'll work out really nicely. But yeah, that turned out good. And overall, I'm quite pleased with how this little power pack has come together. The tensioner looks really good. I'm pleased with that as well. I think it's going to operate really nicely, keeping the belt optimally tensioned. So that's something that we don't have to worry about as we're going forward. And we've got a good stock of these belts, so we don't have to worry about that. Yeah, overall, I'm very pleased with how this turned out. And I think it's going to work out nice for this tracked vehicle. Well, having said that, that's about all I have for this video. What I will end up doing is taking this whole pump motor assembly apart, I will do a little bit of finish welding on it and then throw a coat of paint on it so that it doesn't rust up when we take it out for the first time. It's getting kind of wet outside. So once I've got it painted and that's cured, I'll do a little short showing the assembled power unit, and we can then look forward to the next part of the build, which will be putting everything together and coming up with the chassis. So that's pretty exciting. It's nice to have these larger build components ready to go. The tracks, the engine power unit, all of that will make our chassis build a lot easier, having those components ready to go. I'm really glad that you guys are enjoying this content. It looks like there's a lot of new folks who have joined the channel. That's really exciting. I'm glad to see that, and I really appreciate you guys coming and checking out these videos. So be sure to like and subscribe. Keep your eye out for upcoming videos, and thanks for watching.